Thank you for your patience, ladies and gentlemen. Good morning. Welcome to today's 2020 webinar. We're gonna start very soon. So let me check whether the dog is online. Dog?
I'm here.
Okay, good. So we can start today's 2020 webinar. Because the coming Jaguar release of Apex is a heavy release, we have a lot of new features to demo. And today's webinar will last about 2 hours. Hope Doug can finish it on time. But we also have the recording ready for everybody to use. So if your teammates cannot make this webinar, we will share out the recordings and the PPT later. So don't worry about that. Okay, Doc, you have the ball and you can start.
Hopefully everybody can see my screen. It says MSC Apex Jaguar, what's new beta. I'm going to just quickly figure out why this is not advancing. So we're doing this presentation over 2 days. On the first day, we're going to cover mesh to CAD, not mesh to add. And that will consist of geometry, some new capabilities for transforming mesh into geometry, some new capabilities in meshing, and then some demonstrations and introduction to some attributes capabilities. We're hoping that we get finished in advance of 2 hours today. Tomorrow, we have a big day where we introduce multi-view capabilities, post-processing, and then the major project, a very big project, which is Adams to Nastran loads transfer. So most of the presentation today will be Jim, who all of you know from geometry and meshing in Apex, and I will do a little bit of attributes at the end, and then we'll have a different team take over tomorrow. All of the PowerPoints, all of the models that you will see in the demos today, and movies of all of the demos will be available alongside the beta. Zhanlang, I will get them all zipped for you tomorrow, and then they can be distributed alongside the beta. Not quite sure what the question and answer format is, but we're more than happy to take questions either during the call or at the end. So I think we're going to move and have Jim do this. How do I change the participants? Jim, the presenter.
Just drag the ball on your name.
Okay, Jim, I think you're up. Can't hear you, so if you're mute, which it looks like you are, probably unmute yourself.
Here, James.
Perfect.
Unmuted and unmuted. Okay. All right, so I don't have a huge number of slides, so I think we should get done early, but maybe we'll have a lot of questions, and I'll make sure my demo is very thorough in the new functionality. Once again, I'm going to be presenting the. Can't get my slide. There we go. So I'm going to be presenting first in the geometry section. So in geometry, we have new capabilities in geometry. We have the facet body smoothing, which we've seen before. We have some new enhancements there. We have a very new and exciting thing for geometry directly from mesh, real geometry that can be exported and push, pulled, and edited. I'm looking forward to sharing that. We have a new functionality related called primitives, which is inspired by some Adams functionality, which is another way of creating geometry, and it could be useful for other uses besides Adams. A new way of partitioning solids using an offset, and we have some more export content capabilities. So I'm going to be going through all of these. So facet body smoothing is a new functionality that we just added. There's a new toggle that's added When you're converting the geometry now, it's actually 3 steps now. It's a little bit easier for the facet body creation. On the 3rd step, and I'll be demonstrating this live too, there's a new functionality called Auto Smooth, Identified Faces. What this allows me to do is take very coarse mesh, in many cases can be extremely coarse. If I have smoothing off, where I'm using the previous build of the Apex, the problem is you'll see this faceted will be reflected in the facet body geometry. And when I mesh it, the mesh is going to conform to the facets. And for those familiar with Patran, with the mesh on mesh, this is the same functionality we had before. And this is a similar functionality our competitors have when they're trying to use their types of geometry from mesh, and then they start remeshing, you have this problem. And this can be very significant if you're trying to refine the mesh in an area. Mesh, a similar mesh, it's not as much of a problem, but it could run into issues. Even if I have the same mesh density on here and it just happens to change where the nodes fall, it could fall, a node could fall on a big facet, which could be pretty far from the original curvature. Turn this toggle on and the topology is recognized. It's important. Also, I'll have a smooth facets created, that refined facets, and then I can mesh a fine mesh on it. So that's a new functionality which can really help in certain cases. Now, how do I know when it's going to do this and where it's going to do it? When I turn this button on, this auto smoothing on, or later on when I'm doing the NURBS creation, real geometry, I have another toggle. Either of these buttons are on, and the geometry recognizes a topology, some kind of a topology. So we have recognized cones, torus and spheres, planes, and cylinders. Any of those are recognized, then the smoothing will work. So later on in NURBS will be another thing that'll happen. If it's not recognized, you'll have this unknown color of gray. And in that case, there'll be no smoothing. Even if you have it on, there'll be no smoothing that happens. Important. The colors are important to help you understand what's going on. In the future, we may be able to play tricks where I can tell it faces a certain shape and it'll try to do it. Right now, we have no way of editing. You either have all on or all off. It's either going to be smoothing or not. So you find cases where the smoothing is causing problems, which can happen. Then you would turn this off. For the most part, though, you would keep this on. Most of the time, it does work. The cases where I found it doesn't work is if you have a very, very tiny model or our tolerancing isn't adapting to the size very well. It might think it's going to be a great idea to smooth something, and it's going to smooth it to a bad shape and could distort your model. So it's important that when you're doing this, before you leave the tool, you evaluate what it did. You turn off your mesh, you rotate it around, you look at things, and make sure it made sense before you move on. The reason is I can't go back into this tool once I have geometry created. It's a limitation we have right now in Jaguar. So another important thing is planar faces will become, faceting is not as important with planar faces, but they're not always planar. These faces meet slightly off. And if I use these faces later on to do splitting, like I want to split this piece on this plane back here, if it's not very planar, it can cause some poor splits or have a split to fail. So when you have the blue, it actually makes them more planar and makes them flatter too. Which I think it's been added to facet bodies is now I can add one more geometry tool. We don't support all the geometry tools, and we're trying to incrementally and add the ones that make sense to do that are not too difficult. So right now with Jaguar, we'll be able to do surface split, body split, all the Boolean functionalities, filler, curve split, and add remove vertex. We also happen to have built into that is add remove edge, because any edge that you pick with facet bodies, you can just pick the edge and hit the delete key, it'll go away. And it'll always go away. Unlike real geometry, where it can't remove an edge. So if I cut a hole with real geometry and then add a filler in here, I could probably delete the edges and remove the hole and have it be repaired. But if it's a sharp corner or a change in shape, change in curvature, you'll know with regular geometry, I can't just pick the edge and hit delete and have it go away. I can suppress it, but I can't have it go away. But in facet bodies, you can always remove any vertex or any edge, even if it doesn't make sense to do. It'll let you do it if you ask to. So effectively, we do have add remove edge, or you can always do split. add an edge, and you can remove any edge too by just picking and deleting it. Another thing we added was visual picking. When I was modifying the features or tweaking the topology in the process of creating a facet body, it was picking the edges behind, the faces behind it, it's very, very annoying to do. That's gone now. So it's now visual picking is enabled. In fact, it's enabled when you go into the tool initially. It doesn't make sense to have it off. So two main enhancements to three main enhancements actually to facet bodies. Again, limitations. We still don't support all the tools to facet bodies. We'll be adding tools as it makes sense. Obviously, we'd love to be able to do vertex and edge drag and things like that, but they may be very difficult to add, and it may not make sense to spend that energy and time to do that. And I'll explain why when we get to the nerves creation. So also, when you do have a facet body, when you're meshing, not all the feature meshes can work. So it doesn't do arbitrary holes and round holes and fillets when you're doing meshing on these facet bodies. We're still working on getting them all in. It turns out that round holes are supported under the features. They're supported as an arbitrary hole. You can add round holes, washers, to facet bodies, but the settings that control it under are arbitrary holes. Also smoothing, if you have that smoothing, auto smoothing on, there are cases where it can actually cause trouble. So when you turn on smoothing, anytime you build any nerves or facet body, before you leave the tool, you want to evaluate it, just to make sure there's nothing obvious happening. You can get a false detection of analytical shapes. So typically, once again, it's small models where the tolerances are not as tuned in there. We're working on this, but you can get cases where it thinks it's a plane when it's not a plane, especially with a very slightly curved surface. And right now, we have no way to do that. So we want to be able to have ways of picking a face and saying, no, you're not a plane. Don't flatten that surface, or have you interactively be able to manipulate what face types are going to be. Right now, you don't have a way to do that. The exciting one for me is NURBS geometry creation. We call it NURBS creation because that is the generic shape, arbitrary shape, face, the type that can be defined. But actually, we're by default creating lots of different kinds of shapes, not just NURBS. So an example below, if I shows yellow and purple and blue and red, I'm probably going to actually create other kinds of surfaces, analytical surfaces that I can do push-pull and stuff on. So a NURBS is sort of a fitting pattern to the mesh. Right now, we don't have a lot of options for creating NURBS. We don't have a way to control the smoothing. We don't have a way to control the resolution of NURBS created. It grabs, what it does, it looks at all of the nodes on the mesh and tries to create a shape that matches all of the nodes. So if you have a rough mesh or a rough geometry, rough geometry from the initial mesh, that'll be reflected in it. We have no way to smooth that or control that. Whereas NURBS, generic dedicated NURBS tools that are on the market have lots of options to do things like this. So this is our very first introduction. In fact, this wasn't even part of the original Jaguar Apex release. We were working on this for optimization. It's one of our research. And it turned out that the development team made such progress so quickly that we actually added it into Apex, or we could possibly do with it. Once it's NURBS, though, or we're calling it NURBS in general, once this real geometry is created, I can export that to any other product out there in the market that supports geometry import. So whereas the facet bodies, I could export it, but only we could read it in. We're exporting the facet body using Parasolids tools and using Parasolids formats, but not a lot of other companies out there support that. So we can write it out and read it back into ourselves, the facet body geometry, but we can't pass it to Patran or to CATIA or other types of tools. With the NURBS geometry, I can export that to anything. Parasolid, step, everything else, because you have new export functionality. That's the new exciting thing, and it takes a little bit of skill to learn how to use this effectively. But once again, the same colors will be used in the case of exporting the real geometry. When you create the NURBS geometry, you'll see this button. It'll create both facet body and NURBS. What we mean by that, creating both, is we're always going to create facet bodies. because in the future, a future release, soon, very hopefully the next release, we'll be able to export the facet body and the NURBS. The NURBS is not linked to the mesh because the NURBS can change quite a bit. The curvature can change, the idealization, the edges can change, and it may not be able to directly map nodes and elements back to the NURBS. The facet bodies are very accurate at mapping. We can map loads and all the nodes and everything back very, very reliably, but NURBS may not be the case. What we're doing is we're creating facet bodies and NURBS. And what I can do, though, in the future release is I'll be able to go back in the tool. I'll be able to recover all the topology that you created before, because it may take a while to create all the topology and to make adjustments to the topology, adding edges and merging faces to be just what you want. When that's done, especially in a complicated model, you don't want to do that again. So if I create a NURBS and I find out later on that it's not really the way I wanted it, or maybe even facet bodies, in the future release, I'll be able to come back in. And if I save my facet bodies, I'll have all that work saved, all the splitting and dividing of the faces. Right now, though, however, I can't go back in. Once I have mesh associated with geometry, I can't go back in. So I want to make sure I evaluate that while I'm still in the tool. Now, if you do leave and you need to make changes, well, you can either make changes outside of this tool using our geometry tools, or you have to start over again. They're your choices. Now, there actually is another trick we can play, and I'll get to that a little later on, thanks to Larry Pierce, for certain types of difficult models. But I'll get more of that later on. So again, though, the mesh is not going to be associated with the NURBS we create. None of the attributes and loads and boundary conditions are going to be associated to the NURBS. They're only going to be associated with the facet body. Once exit tool, you can't come back in. That's future. The results are not acceptable when you're in this tool. Just hit undo and split your model up further and try again. That's the basic process you want to do. So you want to stay in this tool. You're satisfied with the result. That's the workflow we have, limited to in Jaguar. Some creation tips with NURBS. The NURBS creation, you can't just take any single shape and convert it to NURBS. It really is a kind of, like if you're an old time user, a Patran user, and you're going to break a model up to do map meshing or the old patches, you want to be able to break up the model into numerically simple geometry. I have some pictures to show you how to do that. If it's too complicated, you'll fail to convert and you'll get a message. How many surfaces have failed? You'll see a face missing. Then you have to break things up further. Now, one of the things that's important to note is some tip examples. So cylinders. If I have this toggle right here turned on, try to use analytical surfaces. It's just like the smoothing above with facet bodies. It sees it's an analytical face and it'll try to convert it to analytical faces with it. It turns out the nodes are all within tolerance. Is turned on and it sees it as a cylinder. It can be one complete cylinder in a hole. One complete hole, it can do it. If you turn this off, or it cannot figure it out, you cannot convert a cylinder in Apex into a NURBS surface. It has to either know it's a cylinder, or you have to split it up into 180-degree faces, at least 180 degree. So any very complicated curvature that curves around on itself, where it's a surface you cannot find some view where you can see the whole surface, then you have to split it up into pieces. And generally speaking, the more pieces you break it up, the better you are. The next thing to do is stay in this tool. You make an attempt. I'll do some of this live. See how it looks? If it looks good, you're done. If you have any suspicion or any concerns, you have to address that while you're in the tool with Jaguar. Here's an example of a workflow. This is a difficult kind of workflow we're going towards. So the initial desire to work on NURBS geometry is in the optimization workflow. Now, obviously, it has many, many benefits beyond optimization. But in optimization, we can get fairly rough models. Convert this to geometry, or I can play with it in Apex or export it to another source. The problem is, as you'll see soon, the mesh that comes in from this optimization has no edges that follow the shape. Whereas if I brought it from CAD, I would have fillets and cylinders and planar faces with edges between them. And the mesh would follow those curvatures, those edges. So when I bring it back in, I have edges I can follow to create my splits. And of course, we easily detect them automatically for you. But if it's an arbitrary mesh like this that has no pattern that matches the shapes, natural or organic model, I can't just detect faces. So the process that I recommend that we do is, for now, we're limited to this little trick we have, is we convert it to one face. Tools to split it up the way we want to use it, because we can have nice long straight edges. You can split in the geometry tools, whereas the mesh doesn't have those edges. You can't use the facet body or NURBS creation tool. Done, I can remesh if I want to, and I want to effectively export this mesh. But Larry Pierce helped us out with a trick. I can convert this, since I have all these faces here, there's a Python script I can run that'll effectively create a section for every single face. What's useful is when I read it back in again, I can automatically detect sections, and it'll automatically recognize all the faces that I created in this session and then convert to NURBS. So this is the workflow we have today if you have these optimization models or scan data. Otherwise, I just try to convert it. I'll get these ugly, useless faces because it doesn't know how to follow. There's no paths that follow good, useful curvature. Other limitations that we have with NURBS creation. So it's a very, very first version of NURBS. We have two main limitations. These aren't really, really significant because especially applied to, once again, these faces that are for organic modeling. One of them is that if my mesh is not really, really smooth, that came from optimization. Now, typically they come from models that are very, very coarse from the way the optimization happened. There's a smoothing that's applied, but smoothing is not perfect. If I can create my NURBS, right now we're using every single node, so it's a very, very high order NURBS. And you can see these wavy patterns in the mesh. And sometimes you can also see a wavy pattern on an edge between analytical geometry and non-analytical geometry. So in these cases happens, I can sometimes split things up here, or I can just prepare a geometry like I would any other geometry repairs, because in this case it would be real geometry. In the case of my coarse mesh right here, what I can do to avoid that problem is mesh with a coarse mesh. So I'm in this case here. Here I took a fairly fine mesh, I exported it as one, or I converted it as one facet body. I split it up using my regular geometry tools, and then I remeshed it. Here I remeshed it with a very fine mesh. Very coarse mesh, just enough to capture the curvature. Wouldn't be enough data to get all these ripples here. It effectively would smooth it out. I also found I can go back and I go into PatchRank, I can do this edit surface refit, and I found it also smooths things out. But in that case, I have some problems with stitching. I have stitching problems too, so you have to be careful. And do a demo, show some of this live. In a Jaguar, and I have a very coarse mesh. This happens to be a shell mesh, but it could just as easily be a TET mesh. It just happens to be a shell mesh from the model I happen to have. So I'm deliberately meshed this coarse, and it's just an ortho mesh. In this sense, model, I'm actually kind of cheating. I'm showing you some of these tricks I have. I do have sections here defined. So what I did was I created this model, and it was shell mesh, and I actually went into this Python tool that Larry Pierce created, and it created a section for every single face to help out with demos and things like that. So I'll show you what the difference is and why this can be useful. That trick that I once again use, and I'm trying to convert to NURBS using these organic models. So I'm going into the tool, same tool as before. And the beginning part of the tool is the same. So if I happen to have attributes already in my model, these attributes can be loads and boundary conditions on pressures of faces. They can be curves or bar meshes. It looks at it, will always split faces where there's a bar mesh. And it can be different sections or different materials. Automatically using these toggles here, break up my model using this information. So if I use that and don't split it ignoring the actual topology of the mesh. I'm just using this information and these angles here. My model and apply breaks up the model. Beautiful. It's great for a demo. But I'm cheating. So let's turn this on and turn this off. What would I get without cheating? It's very similar. But what the difference is, I lost my chamfer in this hole. I lost an edge along here. So I could of course I can come in here using the tools. I can click on this edge. I have a Alt double click. There's my split there. I can continue to split it up. Great tools we have now. It's much easier to work now because I have visual picking turned on. I can add on my splits. So if you're doing demos related to this, and you're trying to just have a lot of work to do, it's a big model, maybe it's a customer model, you can use this trick where you come in, you create the facet body with all the faces that you want, and I can play Larry's PCL, Python, tool. I'm sure Larry will be able to share that with everyone. And it automatically breaks up the model and retains all the faces that I have. And the reason that's important is, besides just the demo aid, once I leave this tool, all the splitting and editing that I did to these faces, I can't come back in this tool. Effectively, I have to start over again if I want to make a change. Undo all I want within this tool and keep trying different splits and faces. But once I leave, I can't come back in. So once again, it's an important thing I want to keep bringing up. It's kind of annoying, and we are going to fix that. But there are ways around that using Larry's tool and just being aware to stay in the tool. So I'm going to go back just to keep myself from screwing up and missing one of my faces. I'm going to go back in and use the attributes of the faces from a previous session just to make it screw up while I'm talking. So actually, I don't want my these features, these vertices here. Yeah, I shouldn't have even have used that. I didn't realize they were in. I can get rid of that by just coming back in here and making this number bigger. That takes care of it. That took care of it. So all those little, I don't want to add any vertices that aren't important in the model. Now is I have this smoothing turned on, right? So I can come in here and I can edit, but you don't have. I come into my export now, my third icon, and it shows all these colors, and these colors represent the kind of geometry that it is. So I'm going to look at this and make sure everything makes sense. So all these blue ones should be planar, and they are, and all of the red ones should be cylinders, they are, and this yellow one is a cone, which makes sense. It's a chamfer. Now, if this yellow one happened to be a fillet in the real world, that's too bad. I don't have enough information to make that a fillet. Maybe in the future, I'll have an option to edit things and turn that into a fillet, in which case it would refine this. It has enough information to calculate what fillet it could be. It happens to be in the original model, this was a chamfer, so that is correct. Now over here, I have faces that look like they should be correct. This looks like it should be a fillet. This looks like it should be a cone. Fillet and cone, but it doesn't recognize it. It doesn't match the tolerances, or maybe this is just an error in our own conversion that we didn't detect this. Either way, there's nothing I can do about it. Now, if I turn the smoothing, actually, I'm going to turn off facet body smoothing. So I turn smoothing off. You'll see everything's great. It means no smoothing is going to happen anywhere. I turn it on. It shows us trying to do smoothing wherever it has a color, not the gray. Now, in the process of just making things simpler, because I want to explain nerves later on, I'm also going to turn on create nerves at the same time, so I can have to go start over again. Actually, no, I'll leave that alone. I'll just create the facet body. So I'm creating the facet body, and here's what's really kind of exciting about this. I'm going to hide my mesh, and look at this smooth thing here. Look what the mesh used to be over here. Used to be, and now I have this beautiful smooth. So now I can mesh a really, really fine mesh on there. Now, it's not perfect in this particular case. I have deliberately picked a model that has some issues. This cone was perfectly matched. Cylinder was matched, but we have a defect probably right here where it didn't understand between the two. So I do have facets here, so that's a problem. Now it has slightly finer mesh. This is deliberately made into a fairly coarse model. If it was slightly finer, this problem goes away. It is in the model, so I wanted to show you that kind of thing that happens. And also, there's another issue that I can run into. Actually, no, that other issue I'll publish link. There's the issue where my edges don't look straight. So now down here, over here is not smooth. It was gray before. So if I come in and put a very smooth mesh on here, my mesh. Let me delete my mesh here so I can make my point here very easily. Turn on very smooth mesh here. You can see some faceting that's happening. It cannot mesh on a curvature that doesn't exist in the definition. Because this wasn't smooth, you can definitely see the faceting. True for all facet bodies in IL. But here now, all of the geometry are in this one arrow over here. Smooth, even this hole over here. So I had some really, really coarse mesh over in this area. Back up some more. Oops, I went too far. Well, I do not see my mesh anymore. It won't come back. So the original geometry over here was very, very, very coarse, and now it's smooth. So now that allows me to work with facet bodies. As long as I'm working in Apex and remeshing my model, facet bodies are just wonderful with the smoothing option turned on. I can do all kinds of really, really coarse meshes and still work with remeshing my model. Of course, all the geometry tools, such as Boolean, not all geometry tools, but Boolean, surface split, add vertex, all these things now work on this geometry. So depending on what I'm doing, depending on the kind of model, especially if it's a model that came from CAD, I can work with this geometry. It's wonderful stuff to work with. I can export it and bring it into other Apex sessions. I'll go all the way back now. Let's talk about facet bodies or NURBS geometry. So NURBS, which is a really exciting part here, has so many cool potential here. Same process before. There's the same topology I had. This time, I'm going to create the NURBS. I still have to create facet bodies, but I don't have to smooth it. I don't care about facet body. I'm probably going to delete it when I'm done. So I can turn that off. The smoothing just saves a little bit of time. And I have all the other settings that are, generally speaking, should be on by default. Now I hit the middle mouse button to create the geometry. It takes longer. It's a lot more mathematics involved. I have my facet body gone. I can just delete it now if I wanted to. But while I'm still on the tool, what you want to do is once you create the facet body or the NURBS, before you leave the tool, just take a look at it. Come over and render it. Look at the shading of it. Compare it to the mesh. Make sure it makes sense with the geometry. Compare it to the shading of the mesh. Make sure it looks good. Once it's good, I can leave the tool, and I could even delete my facet body if I wanted to. Now I have this geometry to work with. Of course, when I delete my facet body, I delete my mesh. My picturing how this is going to be used is if I want to work with the mesh and remesh it, keep all my loads and boundary conditions, I just can work with facet bodies. I don't need to create NURBS. If I'm going to do a lot of heavy geometry editing, if I want to export my, my geometry to another source, then the mesh is not really important. I just want the geometry. We're not doing any associations. Now in the future, it may turn out that we're making really, really good conversions to NURBS, and maybe there's a reason to try to convert the mesh to associate the mesh and loads and boundary conditions to NURBS too. Have NURBS. Now I can come in with all these geometry tools, every geometry tool now. I can remove this piece right here. I could come in and remove the hole, or I could come in to push-pull, editing the geometry, change the hole size. And one of the reasons of not having the mesh now is I don't have to wait for the mesh to update. I want that chamfer there, or maybe I want that chamfer to be fillet. I could delete the chamfer, and then I can come back in and add it as a fillet. Fillet. So now it's actually a fillet. So I have all this functionality. Now you may not be able to manipulate the geometry exactly as it was as original geometry. Everything's not going to convert properly. In fact, we know down here, this is a model I grabbed deliberately. There is an issue here where it did not do a good job between this cylinder and this NURBS right here. It had a squiggly edge right here. And generally speaking, this doesn't happen very often, but it is a target for one of our main things that we're solving. The next release of Apex is working on this thing. It happens sometimes. And also that case where you saw in the other model I had rough geometry from the optimization models. I have a case like this or something doesn't make sense. What I would do is while I'm still in the tool, I could maybe break up the geometry. In this particular case, there's not much I can do about this particular geometry here. But breaking it up separately does often work. In this case here, I just have to fix it. In this case, when I fix it many different ways, and I'm not going to do it live right now, is I can delete these faces, I can pick these edges, and I can revolve them back up, stitch it back up. It's fine. It does work. There's all kinds of ways I can fix this. Locally, I've taken very large automotive floor panel models with hundreds and hundreds of surfaces and see this every once in a while. I'll see this, and we have it less than we ever did before, but we still have it sometimes. I found in every case, just a few little operations, and I was able to repair that. It was important to do. So it's not a big problem. And we are targeting ways of making it even happen less. So once again, though, what's real geometry? I can do anything I want to this, play with the fillets, change the fillets, everything's there. Okay, so it's just wonderful. I can now take mesh, even coarse mesh. Remember how coarse that mesh was in the holes? Now I have this beautiful smooth geometry. My topic on geometry for the CAD-based geometry. Let me just once again bring in this for people doing optimization. I have scan data. Let me just bring in another model to explain what it's like for organic type shapes. We have to do. Importing my mesh. And this model is available and one of the downloads if you'll be able to use this model. This is part of an optimization run. I'm sure many people might have seen this model before. I just take a piece of it now. I think I have my units wrong. Doesn't really matter. This is a very, it looks apparently smooth, but the faceting is quite poor for converting it to geometry. Shapes, the edges don't match what I want it to do. I want to have it split an edge right down this curved area here, but there's no edges that I can pick. So if I convert this facet body, and it takes a while to convert, so it just makes a mess of all these random patches, just like I had in the PowerPoint. So it's not useful to convert this using this face detection here. So what I typically do, if I want to work on a model like this, I turn off all this detection. Make sure my angle is not too coarse. Pick the model and just convert it into one face. Here I'm doing facet bodies, not NURBS. Create one face out of it, which is done. So now I have one face. Delete the mesh, and I'll use our geometry tools. My facet body. I use my geometry tools and split it up. And here's where it takes a little bit of skill. It's not as hard as hex meshing skill, but it takes some skill to understand what NURBS can do. What's the functionality of NURBS? So I have a cylinder here, for example. This is not a true cylinder. Smoothing is not going to work on this. So I have to split this up into at least 180 degrees, if not 290-degree sections here. Anything for the fillets, anything for the outside. I'll be just coming along and splitting this body up, just using split on path, following the this thing, and I'll go all the way down and find a nice shape. I can then go into and use the split, as the first couple splits might take a little bit longer because it's a very complicated model. I can also use the split tool. I want to split and slice it on a plane. Typically, maybe this model I'd slice it a couple of ways down. I'm going to end up continuing to work on this piece and split it up into many pieces. It's not, it can be tedious, but think of the alternative. If I want to create real geometry, this is a heck of a lot easier than the alternative process we had to do in the past. So, broken up, then I can convert to NURBS. So let me show you what I would end up with. Okay, so actually one more step I do. Once I break it up into pieces, I have this ugly mesh, these ugly tessellations in here, and that's what's gonna be converted to NURBS. So what I found very good success is after I'm done breaking it up, I'm gonna remesh this. That's why I want to have also nice rectangular surfaces, so I have a nice clean mesh. And this jagged edge is because I broke it out of a much larger model, make it easier to play with. So when I'm playing around with this, I usually trim this piece off and delete the end. I don't want it to work on all these little sharp teeth on the end. Really fine mesh, that fine mesh, once again, is going to follow all the undulations in this tessellation. I'll gently break it up into a relatively coarse mesh, smooth out the facets in the process, and use that to do the conversion. Import the conversion for this model. So what I did was, let's pretend I broke all this up into pieces. I imported it. Before I exported it, I ran this Python code that took every single one of these faces and added attributes to it. Back in again, I have this model here that I create bracket leg remesh with materials. Actually, it was with sections. It's important, not materials. And my units are, I wasn't paying attention to my import units, so okay, it happened to work this time. So I have this new model now, mesh, and I use a fine mesh. I learned that's probably not the best thing to do. All it is the mesh and a bunch of sections. So I come back into the tool. Now this is an orphan mesh. Now I'm going to use these attributes. I'm not going to split up on the features and find faces. I'm going to use these attributes literally. In specific, I'm using the sections. Now, those are all the faces I created in the previous session, or even the same session in the previous model. That's how I split up the model. Learning what the best splitting up is too. This is what I just did pretty much freehand, splitting the model up. Now I went over to export and see how it's converting. This is an example where my model, I brought in very tiny. I have my units wrong. So everything's very tiny. And what it's seeing here is it's seeing a bunch of shape types that aren't really correct because my model is much, much too tiny. So one of the known limitations right now is our tolerances. Actually, I have the wrong setting here. Our tolerances for size aren't adjusting really well with model. Hopefully that will be addressed in Jaguar. So what I really should see is nothing here. So that's the case. Smoothing and have it convert, because the smoothing is actually going to convert. Try to smooth the shapes aren't really here. Typically, when you have an organic shape like this, it has no real shapes. These aren't not real shapes in here. This is not a real cylinder. It's just being a little bit too, the tolerance is a little too coarse because when I imported it, I forgot to pick inches. In this case, so once again, for organic type shapes, you would leave it off the conversion. I hit middle mouse button to convert this, and this takes a little bit of time to convert. NURBS creation on these organic shapes is kind of slow. So instead of waiting, it takes about a minute to do this. I'm going to move on to presentation, and I'll come back and take a look at what happened. So that's NURBS. There's a lot of practice I want you guys to do on this and play around. This is just the beginning of a huge potential functionality, including automatically finding these faces for me, which is some of our some of our other tools maybe outside of our marketplace can automatically find these faces and it lets you play with them. So that's our goal to head in that direction. Some new things. Next thing we have is geometry primitives. Geometry primitives was created because of needs in Atoms. Atoms had this ability to create these primitive tools, cylinders, blocks, and spheres, and then they actually can boolean them together and modify them and have this history tree and have them all modify even after they've been boolean. We don't have that kind of modeler. We can't create a history tree and boolean things together and then create these and boolean them and add features and then have it make a change and have the whole feature tree update again. That's not the kind of model that we have. So we can't use these exactly the same way as you can in Atoms, but we can create these primitives. Created, there's actually more. I can build create the settings and put them on the model. It works really, really well. And I can change them in the model browser and modify them. But once I start editing them using our geometry tools, I lose this ability to modify them again. Once again, they're really intended for Atoms, but I think these are useful, especially things like spheres and ellipsoids, or if you may make a quick cylinder to punch a hole. These might be much easier to do than going into the sketcher to do it. I can orient them much easier in space, the cylinders, because they can match to the normal geometry, whereas the sketcher needs to have flat geometry right now to match to. So what I'm thinking is these are going to be useful, especially sphere and cylinder, as a way of building models. You're not really going to do the modifications of them. You're not going to keep these parameters. You're going to use them as a primitive. You're going to boolean them or chop them into the model, and then that's all it's going to be used for, just to save some time. Here's an example of a GIF animated. Hopefully this GIF turns out okay. What I'm doing is I'm changing my setting so that every time I create new geometry, it goes into a new part. That's a new feature we have in Apex for this purpose. So now every time I create a new primitive here, it's going to go into a new part. You'll see how my primitive snaps to the normal of my geometry, and I can keep building them. I can edit them. This is showing the preview of the actual shape it's going to create. I'm creating a sphere. I attach the sphere to the center point of the end. Take a cube, lock, and put it on the end. And I'm going to use the transformation. So before you finally place it, hit the middle mouse button. You can use all the transformation tools to manipulate it. And then when you hit the middle mouse button, of course, it's created. You can go into the model browser and all those parts, each of them are in their own part, which is the setting I made a change to. I can double click on these and I can go in and modify the parameters that made these things. I can change the radiuses, I can change their locations, I can change their orientations by manipulating the UTM. Works really well. Now, and that's all fine until I want to make a non-primitive change. That's when it changes. You'll see. So here I'm changing the box dimensions. The icon on the panel shows me the colors of the box dimensions, which match the UTM color, so I can easily tell which one I'm doing. I'm going to hide my surface, and I'm going to go into the Boolean tool and hit the middle mouse button, the Boolean. You'll see you get a message here that your primitives are being just damaged. They're no longer going to be primitives anymore. Now I don't have them in the model browser as a primitive. They're just a regular geometry. I can't modify these parameters anymore because we don't have a history tree of what they came from. So that's one use of primitives. It's not intended. It's really intended for Atoms use, but I think it has some use within Apex as well. Another feature that we just changed, we added, is as a new way to split surfaces. Is split solid models on surfaces. This feature, this offset and so you pick a face and it creates an offset, and you can play with that ball by typing in a dimension or moving it to another surface as a reference. This is the same as it is with the auto surface create. This is supposed to be a GIF that's playing here, but I don't know why it's not playing. So I can split on offsets. It's just this technique was originally envisioned for helping, once again, an optimization where you have a hole and you want to have a non-design region around the hole to preserve the hole shape. It was kind of difficult to make those very common types of offset splits. This works on that example. Also, it can be useful in hex meshing and other uses. So here's an example I have, where I have a model that's broken up, but I want to offset this face some amount. So I don't really know what the offset is. I drag the ball over to here and see it's 4 millimeters. Back to its original surface at 0 millimeters. I see, so I type in here, and you see the offset. This is, even though the face is only not covering the whole area, when you hit middle mouse button, it takes that offset face and extends it to infinity within the part. You can see by right away, I just offsetting this face, I create a split that goes to the whole part. So this saves me a lot of trouble of having to go in and use multiple tools. Before I would have to go into the mid-surfacing tool, use the offset, come into here, extend the surface, then come into here and split on the surface. Now I can do it all in one shot. Just a new convenience tool for optimization, but useful for regular geometry editing for solids. So, another example which is useful, if you create a surface in the original splitting methods, I create a surface to do splitting for hex meshing. Sometimes the surface you create is just a hair too small. So if I go to take a solid, I pick the surface to do a split, it's too small. This particular tool extends the surfaces. It's like when I split on faces with the solids. The surface here, these offset surfaces don't have to be part of the solid. They could be any surface. I can pick any surface to split my solid on, and I can pick an offset of 0 if I want to use the actual surface. It's going to extend that surface as much as it can and do a split. Now, not every single surface can be extended using this tool. Typically, some B surfaces are very complicated shapes you might create using filler or something. Maybe they can't automatically extend. For any kind of offset surface, or any other simple surface, you can extend them automatically by using this tool. So it helps with hex meshing. The thing we add is the step export. So on export, I can take this model. This happens to be a multicellular solid. I can export it with IGES or step. In this case, it's a multicellular solid. It exports all the pieces, and it exports the merged version because it doesn't really know. It can't export. Step and IGES can't have multicellular solids, so it exports pieces like this. For regular geometry, regular surfaces, of course, it exports what you expect to export. Do under file export, step and IGES. Go back into meshing right away. We have a couple enhancements. Mesh control curve now is enhanced to support virtual topology, so I can have suppressed. I can create the mesh control curves and then add, remove virtual topology to the problem. I can also do editing of my geometry. I can manipulate my geometry, adding splits and using vertex and edge drag, and these mesh control curves will be retained as much as possible with no problems. Hex meshing. We're continuing to improve hex meshing, incrementally improving the amount of success rates you have. There's an enhancement with mesh order and IL at FP2. These meshes, if I box pick them because there's a circular mesh pattern here, couldn't be meshed. In Jaguar, I can box pick them and they are meshed. So we're better at picking the order in hex meshing to make it more easy to just pick the solid as one click and not have to be careful of the order. It doesn't work in every single case. There's still cases where you might have to pick the order, but it makes it much easier. We added was the fact that the start and end meshes. Sometimes you have this circular case, like in this example here, but there's no way you can mesh this without having some solid somewhere that has mesh on the start and the end. We increased the number of cases that we recognize the pattern between start and end. That will work. So on FP2, you couldn't do this. You have a mesh part over here and a mesh part over here. It wouldn't work, and now we can do that. So it's more flexible. Very useful. It's very common we have a machine part with different thicknesses. You have this step here, an IL. You couldn't automatically mesh this. You had to put a split up here, right here. Now in Jaguar, all these cases are recognized. We can mesh these cases automatically now if these are the connector faces. So all these can be meshed. Here's an example of the cases in IL, FP2 that couldn't be meshed in red, green ones that could. In Jaguar, all these cases can be meshed. These are really bad topologies here that maybe don't make sense anyway. The remaining red ones. All these cases now can be meshed. Couldn't be meshed before. So it just makes it easier when you're hex meshing. Sometimes it's red. You're like, well, why is that red? What am I going to do? There's just fewer cases that are red, the better it is. Makes it easier to do things. Other areas in meshing, we have a new auto refine button added. So what that does is auto refine right down here, the button in hex meshing. So when you hex mesh, right now you'll have cases where maybe it's some tiny edge or some small feature, and it creates a bad element or an invalid element. So this is an example of the invalid elements are created in IL. This turned on, which is on default by default now. I'm going to get more elements, but it's automatically going to refine the mesh around these bad elements. And you're going to have, generally speaking, you'll have better mesh, fewer bad, fewer failed, and much less invalid elements by having this toggle on. It's not a magic button. This doesn't do this iteratively. So this might take multiple iterations to always remove every single bad element. But it will make a big improvement. Doing it's actually refining the mesh around the edges, around the bad elements to remove them. Incremental surface meshing, the workflow is different now. Before in IL, I want to modify a washer. I only have a few parameters, and I can't modify a feature with a mesh size dependent parameter. In Jaguar, I have all the parameters that you have in regular feature meshing options I can modify. It's a new step process now. So before I had 2, now I have 3 steps here. I have the initial step. I have a step where I can modify the features, and then the final mesh step. Many fewer clicks. Before you had to click out and had escape, and people would get stuck inside feature editing, and a lot of frustrations over there. That's definitely much, much better now. We still haven't fixed the rotation. So before we can change the parameters, or we can change the rotation of the washer. The rotation still has the same limitations as before, except I don't have to hit escape to get out of it anymore. So we're still working on this. We have a lot of things to do in incremental surface meshing. Just one more incremental improvement in that area. Of the workflow now, mesh is clicked on. I click on this washer feature now. I can change the size, and these sizes can still be mesh size dependent. Here I'm copying it to another washer. And now I can leave the incremental surface meshing like before, and I can go into regular meshing and take advantage of these washers. So that's one thing you want to remember. I don't have to use incremental surface meshing to do my meshing. There's some limitations to that. Right now it works with the whole body, and I don't want to mesh the whole body, or I don't want to mesh the whole body with one mesh size. I can use incremental surface meshing just to play with the washers and leave, go into the regular meshing, and shell mesh these things, or go into hex meshing, and I can take advantage of these washers. One of the ways it's going to be more flexible. So known issues with incremental surface meshing. We have a lot to do still. Still only one feature type. We only support the regular washer. More to come in that area. The rotation still requires you to pick on the washer itself, not the new glyph. There are more steps for head plan. We want to do automatic geometry cleanup, and we want to do automatic mesh cleanup, and maybe even items where you can pick the mesh quality you need and iteratively clean up the mesh until it meets that quality, like our competitors can do with batch meshing. Right now, the glyph is too big. In your beta version, it's supposed to be smaller. Also, in the very first stage, the glyph's not supposed to be visible. Improved too. It's going to only show up in the editing stage. A couple of limitations. Quality checks for solid meshes, so hex and elements, which are a very complete set based on what our other industry products have out in the marketplace. We also have a new threshold. Right now, you have problems if you're not so much worried about your quality. You know it's a hex mesh, let's say, and you know there's some bad elements in there. You know Nastran is going to run. You don't want to have our AR prevent you from running the model. So now we have this high risk threshold setting that you can turn on. And incremental in an IL will use this too, as long as I use this gear here or go into application settings and pick it. IL will use that and it'll have much, much higher thresholds. So the goal here is we're going to prevent you from running something that's going to make nastran crash, but we don't care how bad it is. If it's bad, we don't care. As long as it'll keep let nastran run, we'll let it go. So you're not going to get the same kind of feedback where your bad elements are, but if you're just trying to get the model to run, you'll have a much better success rate because of lots of requests of AR checks blocking runs that you want to run anyway. Some things that aren't quite right. In my testing here, I found out in the new test, it was finding a lot of invalid elements with index turned on. It was following a lot of bad elements that weren't bad. So in this case, I have a cube with a 60 by 60 cube with 1 millimeter mesh, and it was finding many, many, many bad elements, which how can you get any better than that? It's a cube with one by, it's simple, yet finding lots of bad elements. So the thresholds were not quite right, and it's giving a misleading output. So we just need to tune this up, get this done right, so we don't have misleading meshes that we have meshed very, very well show up as being bad. So this needs to get taken care of. You'll see this right now in the beta version, and this needs to get very useful thing with quality we added. So you do your quality check, and you find that you have 5 invalid elements. Well, where are they? Well, we have something we added where you can right-click, of course, and say show only, and you see the bad element. Well, where is that relative to anything? Well, right now we can do a grow. You'll see on solid elements that you can keep growing this, and that'll give you a context. But if you're just trying to see the geometry so you can fix it, here I have a new thing. I can right-click on it, show associated geometry. The geometry pops on. I can see exactly where it is. I can zoom into that area, find the small feature, go into vertex edge drag, fix it without having to screw around so much. So here's an example of a GIF where you have that case, show only. I can now use the grow for solid elements, which is nice, new improvement. But still, maybe it's not what I want. I still show associated. Now I can zoom in and find my little tiny edge. I can go into edge vertex drag. I can fix the problem. My bad elements go away, and now it's much easier. So this is a much easier workflow to have some bad feature somewhere in the model. Now, of course, by default, we wouldn't even get that bad mesh because we have this button, this setting for remove small edges automatically. So I had to play some tricks to get that bad element to show up. But you've seen cases where bad elements do show up. This is how you can do that. Bad elements. So nastran interop is the last section we're going to cover, and Doug's going to cover the rest of this. All these abstractions in Apex, fasteners we're going to have, we have these connections, and we have glue, we have all these kinds of high-level things that nastran doesn't understand as a high-level operation. It's just low-level things. So the goal is to be able to preserve these abstractions so I can export my model to nastran, import it back, and recover all these abstractions. When we do this, we added 2 new cards in nastran supports. These 2 new cards, one of them lets me create pairs between keywords. So I can create a word and a string, or a word and a real word, an integer word, and a Boolean. And I have this structure thing that associates Apex abstraction with nastran elements. So effectively, with these 2 words, I can store the name Apex used, the description Apex used, what abstraction it was, and what nastran entities going with that. Now, the goal is for Apex to then read this in and recreate all my abstractions just the way it was in Apex. Read back in, all there. I have a nastran legacy model. Of course, I could copy this pattern. I can write a program to create my own abstractions based on my known model behaviors of my old nastran model, and we'll read them in. They're abstractions we accept. The ability to, we're also, nastran's writing these abstractions to HDF5. So I could run Python, and I could use these abstractions in scripting with results, all of this being written there. How this works, there's an abstract name value pair, has a unique ID, and I can store it, and Apex understands these unique names. Now you can have any name you want, you can do whatever you want with these names. These are special names that Apex understands, and if it understands this to be the name of the object, and understands this to be the description that was used, if it exists. And here's an example of a point mass name value. So I have this abstract structure. is used in conjunction with these. So if I have Apex understands these, so we have a subset, we're not using all of them, every single abstraction is not being supported in this particular reason. Jaguar, where we support beam spans, beam shapes, masses, events, certain kind of events, like constraints, pressures, things like that. Masses are done. So a lot of them are supported. Here's an example of what you'll see. You may not see them together like this in the bulk data file, but I have my names are paired up under this ID. And I have this abstraction, Apex abstraction with that ID, so they're linked, and then the actual Nastran entries that are there. Here's an example of a section, a span. It has the same thing. It has a name. There was no description here because there's not one available. It has all the beams that are using that span. Import, I should get all these back. Here's now HDF5. If I use my HDF5 viewer, I can see all these abstractions. I can see how they all link up, and I can effectively, programmatically use this in my own post-processing automation if I wanted to. There's a lot of potential here. And other uses of these abstractions, we don't have to use them just for Apex abstraction retention. You can use them for any other purposes you want. There's lots of potential out there. Probably opening up Python code right now and start doing some programming on it. Issues, you have to make sure you use the latest Nastran to support this. All abstractions in Apex are supported yet. And right now, with the current beta version, not all of the abstractions will come back into Apex. Some of them will, some won't. Last slide is we also added under coordinate systems, element coordinate system display. Before we only supported shells. Now we added beam elements. So you can see the coordinate display of beam elements also under the verification. So that's the only thing. We have lots of stuff to do on beam still. It's the only thing that made it into Jaguar. I'm done my section. I'm going to sharing.
Hello, Jim. Thanks for your demo. Thanks for your presentation. It's great. So I think we have a lot of questions on the floor. So if you could pick it up right now, that would be great. But we have to make it short and concise. We have to leave enough time to Doug finish his part. Cool. Let me read the question for you so that you can answer it. Sanjay, he says, what's the impact on the pre-existing entries on the existing mesh, such as joins? Does it maintain it, or you indicate loads and boundary conditions are maintained after the interaction is maintained?
You mean on conversion to, just related to conversion to bodies? I'm not sure the context.
I don't know either. Probably I can drop you to
If it's facet bodies, we do maintain all the loads, boundary conditions, sections, spans, everything gets mapped to the facet body. If that's the question, it's still there. Once it's mapped, we have the same limitations as we currently do once it's mapped and you start editing topology with attributes.
Move next question. Sanjay, if you have, if Jim didn't explain the exact answer you're looking for, I will organize a Q&A email later so that everybody can ask the same questions to similar question to James so that James can reply in details, because we are running, we have to catch up the time, so we have to make it quick this time. Another question is, can the abstract definition be used for output request?
Not right now, no. But it's open to whatever, we have good ideas and enhancements for that. Put it out there. Right now, the goal is information that we have that's an abstraction in Apex that Nastran does not retain. Comments, if there's information on the abstraction, in Apex, we can write it out. Now, there may be other things too. Apex has these attributes that you can associate with things. We don't have any current now. We don't have any way to write that out. Maybe that's something else too. We can write out these attributes that are user definable attributes and read them back in too. So there's really no limit. Whatever you can store a name value pair and whatever ways of linking elements and Nastran cards together, we can do this way. So it's really, there's a huge amount of potential, and we haven't even tapped the potential. So we need feedback from the field, customers. It's possible.
Next question. Can I?
Sorry, Caroline, could I just interrupt just briefly there? That you can also write your own abstract and name val cards into the direct text input, right? You can do that manually, or you can do it with a script API, whatever you want to do. I think the idea here is we're just getting started. We really think this is a powerful capability, but we think that you guys will come up with some phenomenal ideas to leverage.
Next question is from Larry. Can I edge drag or vertex drag on the analog geometry created from the facet body? NURBS, but just the facet body.
We don't have that right now, and we probably could, but it would be expensive project. Since NURBS creation seems to be pretty effective, it may be that it's so good at creating NURBS that why would we want to spend the money to do it for facet bodies? Just do it on NURBS. I could be wrong. There could be other use cases, but right now, it's on our long-term list. It's on the bottom of the list because it's very difficult to do. We effectively have to create NURBS behind the scenes, let you drag it, and then turn it back to facet body. So maybe that's how we do it, and maybe that's fine. Right now, we can't do it.
Next question. Why are we continuing both the facet geometry and NURBS geometry? Are there certain workflows that are better for each other?
Yeah, so we're doing both because the facet body is very, very, very good at retaining topology. It's a one-to-one between the mesh and the geometry. It's very easy and very reliable. It's a good way to store topology. Whereas NURBS, it has to fit the smoothness of the mathematics between the NURBS. It may not be able to match the topology one-to-one. So it's risky to just convert my mesh to NURBS, map everything to NURBS, all the loads and BCs to NURBS. It's kind of risky, especially now, early on. So maybe we'll be able to do that in the future. But right now, we're retaining the facet body so that I can go back into the tool and redo it. Right now, of course, I can't go back into the tool. That didn't make it in Jaguar. So right now, we're going to have both. You can, of course, delete the facet body if you don't want it. But if you delete the facet body, you're going to lose your associations if you had associations also, like mesh, or if you had loads and BCs. So for now, we're going to keep both, but that might change in the future.
Okay, next question is, does NURBS or facet geometry conversion carries over the P-shell definitions from the mesh to the geometry?
Yeah, so facet body will retain all the attribution. So I have, yes, so whatever you bring in now from PDF file that we read in, when you convert it to facet body, it will retain that and associate to that new facet body geometry. One exception might be things that we don't, so like if you have a variation, like a variable thickness, we can't convert that to one surface yet. So that'll retain its association to the elements. But anything that's a constant thing that we can map, it goes to the geometry, goes to the facet body geometry.
Okay, next question. Are the primitives hex meshable? If so, will the mesh be updated once the dimensions are changed from the model tree?
I believe so. I haven't tested that one, but I'm sure if it isn't, I would say it's defect.
From Stefan, does the incremental meshing work on the face of a solid body?
Yes, it does. It doesn't work on face. It works on the whole solid body. We do want to make incremental work on faces too, not just entire bodies. But there is a workflow that you can do with hex meshing and incremental with the washers. Right now, there's a defect if the hex mesher ignores the local definitions of the washers, so you'd have to shell mesh it right now and bake it. Hoping that'll be fixed. So it's not as an elegant solution since we do all the faces right now, but you can do it with hex meshing.
I think that's all the questions we got for now. So if you guys have more questions, please put it into the Q&A session so that I can pick it up. So now let's give the ball to dock so that he can finish the rest part.
Alrighty.
Okay.
Now the presenter. I'm going to share. What am I going to share? Screen.
Yeah, you are the presenter right now.
Thank you. I think I am sharing my presentation. Can everybody see it? It's the agenda right now.
So we can move forward.
So I'm going to cover just a few things. I think we've just got three things here. The first part is some changes, enhancements we made to the coordinate system. So basically, in the Jaguar release, we now correctly support node reference and displacement coordinate systems. These are imported, they're persistent, they are correctly passed to the solver, they're correctly exported, and they're handled by post-processing. So this kind of takes away a major pain. I'm going to skip over those slides and just quickly, actually, probably not so quickly, but why can't I find? I've been preparing here before Jim finished. Yeah, so I'm just going to quickly show what you can do. While Apex is coming up, I will talk about what we're doing next. Although we correctly import this information and export it, we don't have tools that will let you manually define or modify nodes reference coordinate systems or manually assign displacement coordinate system to nodes. Of course, if you apply, constraints or motions in rotated local coordinate systems, we do automatically assign the correct displacement coordinate system. You can't do this manually in the current release. So it's very much an import-export capability. Let me see if I import. Let me see. CD. Import the reference coordinate system, and we'll do it by contiguous mesh. So here we've got a super simple model, and I can look at the parts. So I'll look at this part, and I can see we've got a new tab up here for coordinate systems. It's telling me there are no coordinate systems, no reference coordinate systems, no displacement coordinate systems. So let's look at this other one, and I can see the reference coordinate system here is coordinate system 3, and it's assigned to these nodes. When I click on here, I can see that it's all of the nodes in this part. Okay. So let me just quickly check. Look at the PDF. Okay, and here I've got a coordinate system, cord2C, and then if I look for the grids, this looks like it's the first part, so there's no local coordinate system here. Scroll back up here quickly. The wrong file. This is the node coordinate system. Quickly open this node reference coordinate system. Scroll down. I can see here all of these nodes have a reference coordinate system 3. Okay, so if I check which coordinate system, there's only the one coordinate system here, but I can quickly check it, it's the right one. I can see that it's coordinate system 3. If I then modify this coordinate system, I'm going to just rotate it around a little bit, 45 degrees. So I can see the impact there. All of these nodes, their reference coordinate system was based on this local coordinate system. When I rotated the coordinate system around, the entire, all of the nodes moved around too. Now, if I export this model, the webinar coordinate system, Nastran, modified. We'll open up this file and I can see coordinate system. I'll just cut this guy out. So this is in modified, or the similar one here. Okay, and I can see the coordinate system is the same, the origin is the same, and you can see the last 3 digits here. It's not obvious that it rotated at 45 degrees, but you can see that it's been updated. Okay, so the reference coordinate systems are correctly read in. They are the nodal positions are dependent upon the local coordinate system, and we write them back out with exactly the same coordinate system. The limitation we really have here is you cannot manually define the coordinate systems in any particular reference coordinate system, just an import-export case. Okay, now next up, I'm going to read in the next file, which has displacement coordinate systems. So when I look at this part, I can see in my coordinate system that all of these nodes are defined in the local coordinate system. Now I'm going to go ahead and put this guy into the analysis scene and run the analysis. Doing that, we'll just quickly check the nodal, quickly check the deck. So I can see I've got coordinate system 2 here. And then if I find the grids, they're obvious, but these, all of these 2s are the analysis coordinate system. So every node in this part was imported with a displacement coordinate system of 2. Post processing. I can see that my model looks pretty reasonable. I'm going to go ahead and do a vector plot of the reaction forces. So I can see my resultant here is as you would expect. It's a radial constraint, but let me switch that off and just switch on the components. So here you can see I'm looking at the responses in the global system. So you can, the X, Y's, and Z's are aligned with the global system. But if I choose local, you can see very clearly that the impact of the displacement coordinate system is being reflected here. You can clearly see the direction. Switch off these guys. You can see that the X, which will be the radial in this cylindrical coordinate system, is in the correct direction. Okay, so that is analysis displacement. As I said, in the future, we will add support for creating nodes, probing them in local coordinate systems. We will probably support definition, not just on individual nodes, but definition coordinate system for parts. So a part can be assigned a part reference coordinate system, and all of the entities, not just nodes, all of the entities in that part will be defined relative to that part coordinate system. That then makes it very easy in Apex to just go in and modify the part coordinate system. It would just, of course, it will be assemblies. So I can easily rotate parts or easily rotate entire assemblies just by modifying the coordinate system. These coordinate systems will also be written out to the Nastran deck. And we'll also support manual assignment of displacement coordinate systems to basically arbitrary collections of nodes. So picking parts, assemblies, bodies, or just a window picking a bunch of nodes and assigning a displacement coordinate system to those. These are not in the current release, but they are something that we're looking at adding in a future release. So that's coordinate system enhancements. We've also extended the mesh independent tie glue for the guys who've been here from the beginning. Previously in Apex, we defined glue only between bodies. So you could do geometry bodies or mesh bodies, and you could just window pick a bunch of bodies and the system would automatically find pairs of bodies and create glue between them. And this worked really, really well for most people. It did have two problems. One, and the most significant problem, was that you could not import glue from the Nastran model because Nastran doesn't know anything about mesh bodies, and the way we create mesh bodies is dependent on how you choose to import the model. So the biggest problem with the body-based approach was the lack of the ability to correctly import models from that. Out of post-processing here. And import geometry here. Mesh dependent tie. We're going to import geometry. Okay. And I'm going to go ahead and mesh this. A 5mm mesh. Okay. I'll just quickly create a section because glue thicknesses. There we go. So what we always did in the past was automatic, and you can still see we have this. We've got automatically defined glue, and now we have this manually defined pair. Let's just work through the automatic for a minute. So I can just pick the bodies and what high field blah blah blah. Must have forgotten to assign this section. Didn't put a value on it. 0.5. Assign the section to here. And my glue, automatic. And so the automatic automatically creates all these pairs of glue. And if I look at, say, this guy, the outline is the extent of the two bodies. So I can clearly see here, I've got the full tube and the full end plate, and then the purple and the gray are the individual patches. I'll go ahead and delete this. Then we'll try something different with the new tool. So I'm going to manually define some pairs. Okay, so in this case, I can choose to build pairs from any of the things you see here in the pick menu. So I can pick solids, I can pick bodies just like I always did, or I can pick cells or faces or individual elements of any type. So for now, I'm going to just go in here and pick these two faces. Solid. Actually, let me just switch these meshes off so that it's more obvious. I'm going to pick this face on the one side, and then I'll just pick this whole tube on the other side. Okay. And here I can see now when I show this guy. I have the whole tube as I had before, but now I've got a much smaller region of the model. Yeah, I've only got these few elements. Okay, so I'm going to go ahead and delete that guy again. I'll switch the elements back on this time. And I think what we'll do this time is I'll do the same thing. I'll pick those faces. This is quite a nice small region. And then I'm going to just hide this guy. I'm going to go in and just pick some elements on the other side. So maybe I just want this single row of elements here. Okay. The glue. So now I've got much tighter control. Maybe I only wanted it to glue to those elements and not the ones on the other side. So I can manually create glue between any types of side, right? Geometry on one side, elements on the other side, whatever combination I need to do. Okay. Finally, I'm going to just show what happens when we import a model. I'm going to import this guy. I'll preview it. So here we can see the cards, the BC body, BConnect, BConPRG, all of these cards. In releases before Jaguar, all of these keywords were unsupported. Okay. I'm just going to import them. We can see that they were actually imported, not skipped. They weren't put into direct text import. So everything here is in good shape. I managed to import this model. Oops. This model complete with all of the glue. I look at the individual glue. See here. Just do show only on this. Okay. I can see the glue patch. And let's say I want to just edit this guy. So by editing this glue, I can see the extents of the BC bodies. This is the BC body on this side, and then this is the one on the other side. So I still have these enormous BC bodies, which is probably fine for this model, but sometimes you want some more fine-grained control than this. Let me just go ahead and delete this guy for now. And then I'm going to go to my handy Geometry from Mesh tool. And I'm going to go ahead and just create some geometry from this mesh. Now, I think Sanjay was asking previously whether all of the materials and properties, etc., were retained, and they are. So this is a geometry body with an associated mesh. But I can see around here that it hasn't really created the kind of regions that I would like. So I'm going to edit this, and I'm going to just merge the faces. I'm going to merge this face, the one on the bottom. I've got one nice clean region there. I'm going to merge this face here, bottom. Okay. And then I'm going to go back in and recreate my glue. That's a good warning you have about making sure you preserve all of those changes. I frequently forget.
Yep.
So now I'm going to go back in here and I'm going to manually create my glue. I actually have geometry here, so I can just pick those faces. Okay, pick the right filter. I can just pick this face on one side, and then I can pick, yes, this mesh body on the other side. Go ahead and create my glue. So let me try that again. I think I messed that up. Clear everything. Faces on this side, and and then on the, and here we can see the glue. If I exit this tool, so now I can see on this side I just have this small region of glue. I've got very fine grained control over what I'm gluing. I didn't really care, so I've got all of the tube there. Okay, so those are the enhancements we've made to glue. They really are two big benefits. One benefit we see is you can now correctly import glue, so you don't lose that information when you import your model. And the sort of sub benefit is you have very tight, fine-grained control over the scope that you glue. So if you only want to glue particular elements down to the individual element level, it's to do that with this new tool. Okay, the last thing that I'm going to show is our part replace workflow. So our part replace workflow is pretty straightforward. It does exactly what it says. You have a model, an assembly model, let's say, and you get an update from your design group. And one of the parts has changed. What do you do? So with this tool, you can simply select the part that you want to replace, and the system will attempt to you choose the new part, the new CAD geometry that you want to replace it with, and the system will automatically attempt to update the model to incorporate the new part, mapping all of the meshes, materials, loads, constraints, glue, joints, connectors, everything that was attached to the old model. We'll attempt to attach it to the new model. Okay, so this again is the first iteration of this tool, and it does have some limitations. But for now, I'm going to just go ahead and show you what it does. Have a model, place demo. No, sounds like the right one. We have our landing gear model. Go in here and just post-process this. So we can see we've got a force on the bottom here. The gear is constrained at the top. There's various joints here and bushings here. This little post-processing artifact here. So basically a lot of joints, etc., in this model. And you can see the model kind of, you get an idea of the connectivity by looking at this deformed shape. So if I go back out and I say, okay, well, let's say I got a new design for this part here. Okay, so from this part here, I can see, let me see, model, this a little bit, find where this part is, and take a look at the mesh here. So I can see I've got a 6mm mesh. It's got linear elements, etc., curvature refinement, a whole bunch of options. Here, I can also see, if I look at the part, I inadvertently deleted that part. Let me see. So let me just look at the properties of this part. I can see it's made of this material 2. It's got no loads and boundary conditions associated with it. I can see it does have a joint here. connecting the blue part to the grey part. It's got another joint here. And then at this end, it's got a bushing connector one here, connecting it. Okay, so I can see that it's got a rotational stiffness of some value there. Okay, so let's imagine now I've got a replacement part here, and I want to look at the model by replacing that part. So I can right click on my part and do part replace. Then I navigate my way to the new part. I find it here, this Phillips 3, and I open it up. I'm presented with the part replace panel, and the part replace panel shows all of the objects, all of the properties or objects associated with the part I'm replacing. So here you can see that it found some geometry, it found a mesh, materials, it found a connector at this end, and it found some joints. It looks like there's a joint and a bushing at this end. I didn't realize that. Okay, and then I can see from the status column, I can see all of these green check boxes. Now that tells me that the system found and is very confident that it managed to map the old representation onto the new representation. So if there were any of these check boxes were warnings or errors, then it would show me that I have a problem, and then we have a workflow that allows us to manually correct that. The indication on this side is, do I actually want to replace the joint, or do I want to just leave it off? So I could either accept it or not. I probably shouldn't have done that, but we'll leave them on for now. And then at the top here, we've got sort of three options. I can see the new part. I can also show the old part, just the old part, both parts, just the new part. I can easily see what I'm doing here. It would have been much, much better to have this operate with multiple viewports, but unfortunately we finished development of this tool before we implemented multi-viewports. So in a future release, we will upgrade this tool so that you can see side-by-side views, the old part in one side and the new part in the other. Okay, so once I'm happy that with everything is going here, I can then go ahead and complete this mapping. Choice, I can either, if I'm super confident, I can choose to delete the original part. And at that point, my model should just run. It should just run automatically and be in good shape. I'm going to switch this off for now, just to show what happens if I don't feel super confident. I'm going to confirm these changes. Okay, and down here you can see what's happening. As it has created a new version of this part alongside the old one. Okay, so it's got this replace part alongside the original, and I can see each of these joints, replace, 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 and also this connector one replace. So what it's done is it's left all of the original geometry in place, and all of the original connections, etc. All of those things are in place, alongside the old and the new beside each other. It's your responsibility as a user to then go in and make sure that you don't have both parts in the assembly when you do your simulation. If I look at the mesh properties here, see it preserved the 6mm mesh. You need to trust me that all of these other things, all these other mesh settings were retained, but that was should have happened. So let me just quickly do an undo on this. And the undo problem. Here it is. Okay, so actually I'm not super confident of this, so I'm going to just close. And I'm going to start over again with replace this guy. And this time I'm going to delete the original part. I'm just going to accept everything. I'm going to delete the original part and exit. When I look at the tree, I don't see any of those duplicates. All of the joints have simply been replaced. Okay. I think look at this connector, connector 1. See, it's still got the original stiffness, rotational stiffness that we have. So that's the part replaced. Now, if I also, that was a super easy demo because we were able to actually replace every single property of that part that we found. But let's try one where that doesn't work. I think this one here has some problems that we're unable to do. So what it's telling me here is some reason. I'm entirely sure where that mesh disappeared. But here we can see, let me quickly. So if I look at these joints, I can see that this joint is shown as broken. If I look at the old, I can see the old. If I look at the new, I can see the new. What I can do here is I can just double click here and I get to see the object properties for this joint. And if I look at the first end of this joint, I see it looks good. I can see that it's attached to this face of the solid. I'm going to accept that and jump on the second one. And I can see that there's nothing lighting up here. So it's, for some reason, it's not connected to this part. So I'm going to go in and just pick this face. Not quite going right with this demo. Effectively, we've done what we wanted to do there. Okay, so for broken objects, I can simply go in and define the attachment regions. So if you think about most things like joints and loads and boundary conditions, they mostly fail to map because we're unable to find the application region on the new part from the old part. And so this tool, correction tool, is simply an application region finder. You just fire up the tool, you find the first end of the joint, it looks good. I'm not entirely sure why it's not. I think there's a slight, it's like it's found the same end twice. Let me go to the other side. I'm just going to quit here because this doesn't look like it's going to work. But the basic principle is find the broken objects and just repair them manually by switching the application regions. It does look like there's some lack of robustness here in this build. The build I'm using is not the beta. We're still about a week away from beta, so hopefully we'll get those bugs fixed before you guys get it. There are some constraints, as I said previously. Number one, we only support parts with solid bodies. So in the current release, only solids, we don't support meshes. We do support meshes, mesh controls such as seeds, seed points, all of those things. Materials, loads, constraints, connectors, joints, point lances, clearance sensors, and motion envelopes. Those are actually only available for this motion designer product, so it doesn't really apply to you guys. What is not supported, which we will add in future releases, are parts containing multiple solids, parts containing surfaces and curves, discrete tie, so those are node ties, etc., glue, and glue and point sensors. And today, you can only choose to replace the part with an external part. So if you noticed when I did part replace, I had to go out to the disk and find the CAD model and do the replace there. We do recognize this workflow is a little awkward, and maybe you want to import the part or create the part or actually copy the part and make a modification of it, and then use that as your replacement part. So these, the items here under currently unsupported, those are gaps in the capability that we will address in a future release. I think there is some additional information in the PowerPoint. I will go through that. It explains basically what I just showed you in the demo. Okay, and I think that is that's it for today. I don't know, Zan Lang, if there were any questions for this second part of the demo. If there are, we can take.
Yes, I think I have received several questions. So the first question is, will the beta release have new API functionality?
Yes, it will. In tomorrow's presentation, we're talking about the scripting enhancements for this release, so it's not part of these, but yes, there are new scripting APIs.
Second question is, can the new glue contact tool therefore be used to glue an edge to a surface or to create a lap joint instead of the default two surfaces?
So we don't support gluing of beams. So it depends what you mean by an edge. If you have an edge of a curve and the curve has got beam elements, that will not be supported. But yes, you can do all of the same gluing operations that you can do with bodies today. So if you have two perpendicular plates, you're gluing the edge of one to the face of another, then you can absolutely do that with the manual replace tool today.
Okay, how is the mesh independent tie different than glues?
Independent tie is just what we call glue in Apex.
Change the name.
We moved away from the name glue because we will be adding adhesives in a near-term release. We wanted to avoid confusion over using the word glue and the word adhesives. So we have a whole bunch of mesh ties. Mesh ties, you know, they don't represent any real physical connection, right? So we have joints, those represent real joints. We have fasteners and connectors, those represent real fasteners and connectors. We will add adhesive joints where there will be modeling the adhesive. We will be adding seam connectors for things like seam weld. But these ties, the mesh dependent tie and the mesh independent tie, those are just, you know, those are just numerical tricks to join meshes together where you're not specifically modeling the fastener. Yes, so mesh dependent tie and mesh independent tie is just glue.
Okay, and does this work with multiple parts if two adjoining parts were changed?
Say that again, I didn't quite understand.
Does this work with multiple parts if two adjoining parts were changed? So I think this question is talking about the import geometry change of the geometry.
Yes, it will be, you're replacing a single part, but the part can be connected to as many pieces of geometry as you want. So in this case, you can see it was only connected to two, but yeah, it can be connected to absolutely anything.
I think that's all the questions I have. Let me check. Okay, there is one more to further. Okay, I think it's related to the question of the second question. So to further explain my glue question, if two plates overlap, by default, all the overlapping elements will be glued. I'll be able to delete it and only select the edge of one surface, connect to the other surface to present a edge weld.
I think the best bet is to try that in the beta. I'm pretty confident you can do that, but I haven't personally tried it. Give it a try. in the beta and see if it works. And if it doesn't, then let us know and we can go ahead and add it. I'm pretty certain it works because we support that configuration. We support that configuration when you do body picking. So I'm pretty sure it will work here, but give it a try and let us know.
Okay.
One thing to note is that with the manual glue, the elements can be distributed across multiple parts. So the elements can be distributed anywhere in the model. They don't have to be in a single mesh body. They don't have to be even in a single part. So you can glue regions from 3 different parts to regions of 2 different parts. It's completely arbitrary how you do the gluing.
The next question is back to the glue question. So since the word glue is being replaced, will all the videos that reference glue will be copied, replaced as well?
That would happen, yes. I can't guarantee that it's going to happen. By the way, the mesh independent tag is not renamed in this release. It was renamed two releases ago. So this is not a new change.
That's all the questions I have on the floor today. So, ladies and gentlemen, if you have more questions, please email Doc. I have already summarized all the questions, so I will send to Jim and Doc for their quick response, and we will sort them out in an email so that everybody can follow up. Right. Cool. I think that's today's content, and tomorrow morning we will continue the beta release, focus on the Adams card load transfer stuff. So, which is very important. And please bring in more people in your team who are interested in these functionalities to attend the webinar. Thank you. Thank you, Doc. Thank you, Jim, for the help.
Thank you, guys.